We can learn a lot from this video. This is AMD talking with PlayStation. It's AMD's Jack Quinn, their Senior Vice President of, Computing and Graphics Group, and and Sony's Mark Cerny, who is the PlayStation lead architect. And AMD has been working extremely closely with PlayStation on Project Amethyst. So this is working on hardware advancements as well as software advancements, neural rendering techniques. I mean, FSR4 was part of Project Amethyst. And they're talking about the future of AMD graphics technology, and then also gets us some juicy details, like not exactly a release date for the PlayStation 6, but they do use the words "a few years' time." Now, this is incredibly exciting, but first, I know I've roasted some of you for your terrible desks in the past, but if I'm being honest, mine has been a disaster since I moved a year ago. It was supposed to be a corner desk, but I just had the two end pieces stuck together, couldn't adjust the height, the top was breaking off, and I couldn't attach a mic stand to grip. There is no cable management. It's a real mess. But thanks to the E7 Pro standing desk from today's sponsor, Flexispot, everything is so much better. The 25-inch to 50.6-inch height adjustment range lets me get into perfect position for sitting, where my chair armrests can perfectly align to the desk, but also switch into standing mode for long editing sessions, which is great for my back and health. But also, the desk comes with great cable management with a magnetic cover as well as a cable tray along the back, which allows for a much cleaner look. My wife is pleased. The dual motor 3-stage semi-C leg structure allows for 440-pound static capacity stability and also amazing strength for lifting. Everyone I know who has seen Flexispot desks ends up wanting one. A while back, my wife got one, and honestly, her desk before was terrible as well. Anyway, now all the other teachers at her school keep asking for one, and actually, Flexispot has sponsored many of them with desk upgrades as well. Honestly, with a 15-year warranty and 30-day risk-free return service, there is no reason not to upgrade to a Flexispot desk today. Follow the link in the video description and/or pinned comment to check out Flexispot's mega sale and use my code YTE730 to save an extra $30 off. And if you have a limited budget, also check out the E7. Follow the link to learn more. Okay, a few years' time. So what does that mean exactly? Well, again, we're not getting exactly a release date for the PS6 here, but it sounds like 2028 or later, because, I mean, if you meant a couple of years, meaning 2 years, you would have said a couple of years. If you say a year, that's one. Saying a few generally implies 3 or more. Somewhere in the 3-4 range is what people would commonly use for the words a few. So I would expect 2028 at the earliest for PlayStation 6 based on this. Now, I also think that that makes sense, because if you look at the fact that console pricing usually by this point in the generation would have dropped significantly. It hasn't. In fact, console pricing has actually increased. I mean, Xbox consoles are insane right now. And then the PlayStation 5 Pro was trying to show, what could the latest technology do at this time at a price that's already higher than most people want to spend on a console. And what's going on here? Well, we just haven't seen that the process nodes for computer chips really drop in price the way that they used to mid-console generation. So I really think it makes sense to wait for more process node advancement and for these technologies that they're talking about in this video to mature and actually be ready so that you're actually delivering a generational upgrade. Now, what are the technologies that they talk about in this video? There's 3 main technologies that they talk about, and I'll be honest, they don't go into quite as much detail as I would have liked, but they do give a good idea for what is the focus of this hardware generation, which again, while we'll see this in PS6, this is also where AMD is doing their R&D development for their computer graphics. So the first thing they talk about is neural arrays. So they describe this as a collection of compute units connected to share and process data to work together like a single AI engine, unlocking the next generation of neural rendering. So basically, they're going to have better machine learning acceleration than what they currently offer on current generations of PlayStation and AMD desktop GPUs. Now, AMD has already made some advancements with their 9000 series for AI acceleration, but this seems to be a step beyond that. And they talk about in this video specifically further advancements of FSR and PSSR and ray regeneration. So what they're referencing there is specific things like, in other words, FSR4 is already looking great. It's a huge advancements over what we had previously. And PSSR is currently not looking amazing, but there's promised to be a version of that that's more similar to FSR4 that should be a solid advancement there, even on something like the PS5 Pro. But what it sounds like they're talking about here is being able to go to an even higher level with that. And there is definitely room for improvement. Like FSR4 looks great, and it's not quite as good as DLSS for transformer model upscaling. So I think there's definitely room to improve there. And this seems like it's designed to power that. But they also mentioned improvements to ray regeneration. Now, that's interesting phrasing because ray regeneration isn't even out yet. Now, ray regeneration is AMD's take on an AI denoiser for path tracing, which NVIDIA calls ray reconstruction and has had several revisions on that. When they moved that to a transformer model, it looked so much better than the original version. So what this sounds like to me is that AMD's ray regeneration, which is promised to come out in the second half of this year, as part of FSR Redstone, it sounds like there's already work on how that could be even better when they get to this further generation of hardware with better neural arrays for better neural rendering. Also, if you look at previous Project Amethyst videos talking about the AMD and PlayStation collaborations, there's a lot of talk about trying to get neural rendering even more available to game developers, see what they want to do with that. So that's interesting as far as the future of gaming as well. And I have a lot of thoughts on when is neural rendering going to be a big part of game development. But I'm going to hold off on that until I also talk about the ray tracing advancements, because then I'll give you kind of my crystal ball future predictions, as kind of talking about both of these together. But that's the other big hardware advancement they talked about here. Well, also universal compression, but let's talk about Radiance cores. So Radiance cores are apparently a new dedicated ray traversal hardware designed to deliver high-performance real-time ray tracing and path tracing for ultimate immersion. Now, there's some important details here. Notice that they're saying that this is dedicated ray traversal hardware. Now, my understanding of AMD's current hardware-based ray tracing is that it doesn't do ray traversal. There's more than one thing happening when you trace those rays, guys. Okay, so that you have to calculate ray intersections, and I believe AMD has hardware acceleration of that. But then there's also ray traversal, which I don't think has dedicated hardware acceleration. I think they're throwing that currently back more over to their general compute units. Again, some of this is a little over my complete area of expertise, but that's how I understand it currently. So what this looks like is they're developing dedicated ray tracing cores called Radiance cores that will also accelerate ray traversal. And they mention in this video not having to take up some of the compute unit power from doing its normal job of actually just doing your more traditional rendering techniques. So AMD's current hardware kind of has more of it being shared, and you're kind of shoves some ray tracing acceleration into the compute unit. And this looks like moving it over more to its own dedicated cores. And they do mention that that should make path tracing more doable for them. So this sounds like definitely that seems to be a target for the next generation of PlayStation hardware, is to be able to do path tracing. And so with advancements in their upscaling technologies, including ray reconstruction, an AI-based denoiser for the ray regeneration, their ray reconstruction competitor, right? That's designed for path tracing workloads. And then this, mentioning getting path tracing up and running, it really looks like PlayStation wants the PS6 to be capable of path tracing. With high quality, upscaling and AI denoising going along with that, and seems to be a target for their future console. Because if you look at what would it take to try to get what seems to be a worthwhile generational leap, based on what we're doing right now, it seems like if a console could pull off actually high quality path tracing, at least enough perceived resolution, if they get enough, high quality upscaling and AI denoising, that could deliver that. So then there's the question of, so when do we move into a world where games are primarily developed around path tracing? Because we know that game developers would like to be able to do that, because if you don't have to bake lighting or anything like that, if your game development process is just all the lighting gets done realistically by path tracing, as part of the game design process, we've seen developers talk about how that can speed up their development timelines. And game development budgets right now have ballooned out of control, without game sales necessarily picking up over the last few years. So if budgets are going up and sales are kind of remaining a bit stagnant, then something needs to give, right? So one place would be to reduce development budgets by saving time in the development process. And ideally, good path tracing can also just be an advancement visually, as well. So you could see this being a desirable thing for game developers. But here's where I'm going to say that, okay, so does that start happening when we get the PS6 in a few years, maybe 2028? And my thoughts on that are, I don't think 2028, even if that's when we get the PS6, is when we'll start seeing games just completely designed around all of this. And the reason is cross-gen periods and cross-gen games. We already saw with the PS5 generation that the PS4 cross-gen period was very extended, well beyond what we used to see with previous console generations. And again, part of that is games are so expensive to develop now and their timelines are so long. To recoup that cost, you need to sell huge numbers. And so if you just launch a new console, you might even have a few million consoles out there, but you need to sell millions of copies, and not everybody with the console is going to buy it, right? So you might need to rely on the PS5 install base to sell enough copies of a game well into the PS6 launch cycle. And I would expect that that's going to be an even longer extended cross-gen period compared to what we saw even with the PS5, PS4 cross-gen period. It's really only now that it kind of feels like a lot of games are coming out just specifically designed for the PS5 generation. So I really think that the PS6 generation, that'll be even accelerated because, again, of the slowing down of process node advancements, the ballooning of game budgets, etc. So I think we could be into 2030 or farther before we start seeing at least a large percentage of games launching with this whole path tracing and neural rendering techniques kind of as a huge game development philosophy. Now, it's possible that we'll see some maybe Sony exclusives or something like PS6 exclusives that are not cross-gen to show off what this can do. And I'm sure there'll be specific game developers that really want to take advantage of these features that do go all in on it right off the bat. But I think it could be a while before most games would start to just be targeting this level of technology. That would be my guess. Crystal balls are, inherently going to have some inaccuracy. But Again, that's also my thoughts on the neural rendering, because right now we have neural rendering with, AI upscaling and things like that. But it's also possible, like I said, that game developers could get more access to machine learning within their games themselves, and we'll have to see where that goes. But again, I think until we start seeing games targeted specifically at the PS6 without a cross-gen period back to the PS5, before I think we'd start seeing at least a lot of that. Now, there is still one major technology here they talked about that I haven't gone over yet, which is universal compression. Now, they describe this as a new system that evaluates and compresses all available data within the GPU to dramatically reduce memory bandwidth usage and deliver new levels of performance with greater efficiency. And again, that's all we really have to go off of at this point. But what I will say is that memory bandwidth is a really big deal in a GPU and how fast it can perform. So if this does offer meaningful compression for all available data without any kind of real major downside, this could, help deliver a huge performance gain on a lot of stuff, and how that could have synergistic effects with things like ray tracing, path tracing, and neural rendering techniques, because it is talking about all data being compressed on within the GPU. So that sounds like it could potentially deliver some big performance wins. But for all of this stuff, we're going to have to see how it plays out once we actually have it. But I thought that was really interesting to at least get a peek at things and maybe an idea of when to expect a PS6. Now, will we get the AMD PC GPUs with these technologies before we get a PS6? I mean, that's certainly possible, but we don't really know. It's also possible that a PS6 would lead with these technologies before we see them in the PC space and the GPUs come afterwards. So, we'll have to see, okay? Now, this is not the only big news today. Sorry, this is what I meant to click on. We also have Intel announcing some big stuff with XeSS 3 with XeSS MFG, so multi-frame generation. Now, this was announced at Intel's Tech Tour 2025, and this is their next major revision for their upscaling technology. Now, they really focused on multi-frame generation. So the idea of this is similar to what we get with NVIDIA's DLSS multi-frame generation. Interestingly, AMD has not yet talked about a multi-frame generation technology, although AMD has talked about at least a machine learning-based frame generation to replace their current version, which is not machine learning-based. And that's coming with Project Redstone, which is promised for second half of this year. Anyway, but XeSS multi-frame generation is being discussed here. And again, it's talking about pretty much the same thing we've been going on with frame generation in general, but just the fact that you can take your previous and new frame, and now rather than interpolate one frame in between, they can interpolate up to 3 frames in between, offering up to a 4x frame rate improvement. Minus any performance overhead, etc. So basically the same thing we've seen with DLSS multi-frame generation, at least in the overall big picture theory. Now, how does it actually look? How performant is it? All of those things are still questions that we won't see answers to until this actually is out in the wild, which it doesn't seem to be yet. Now, they also talk about the super resolution technologies. But again, none of this really seems like anything particularly different than what we've seen before, although there was at least discussion of backwards compatibility. So, and it was also unclear to me whether they're saying that XeSS 3 is also a major revision of their super resolution technology or just the frame generation. Maybe I'm missing that, but in the articles I've seen, it's been seeming to mostly focus on the multi-frame generation aspect of this. But they do promise backwards compatibility to all ARC GPUs with XMX hardware, which would include their A-series Core Ultra 200 Xe2 GPUs and future ARC B-series products, which is pretty cool. So there's a lot of backwards compatibility there. And they also mention a driver override feature that will let you select the 2x, 3x, or 4x modes for frame generation, similar to how NVIDIA has offered that driver override feature within their software. So that's cool. The other thing that they talk about here is just a really good thing in general for the PC gaming space. And this seems to be Intel just promising their participation in this. This is Microsoft's Advanced Shader Delivery System. I've mentioned this in other news videos, but let's make sure we understand what a big deal this will be if this comes out and actually works, okay? Right now, we know that shader compilation stutters are the bane of so many PC games, where the first time you encounter a shader, there's a stutter as it compiles. Now, a lot of games offer a shader pre-compilation step where you wait several minutes, different for different games, but it can be quite a while for shaders to compile before you first start playing the game. However, even games that do that often miss some shaders, so you still get some shader compilation stutter while gaming. But also, it's annoying to sit through those long shader pre-compilation burns. So Microsoft's Advanced Shader Delivery System is designed to handle the shader compilation in the cloud and allow you to just download the pre-compiled shaders. And Intel is talking about their participation in that. So pre-compiled shader distribution. So the idea is this would optimize launch times for a game because you don't have to do the shader pre-compilation step. And it should then reduce stuttering because ideally this would be a more thorough shader compilation that doesn't miss things. And it should then hopefully be able to just download updates through the cloud. Now, for this to work properly, and again, I want to be clear, Intel's talking about their participation in this, but this should work for AMD and NVIDIA as well if they all participate and get this working. The idea right now is that unlike gaming consoles like a PS5, where there's one hardware version, essentially, maybe you have the Pro version as well, but there's extremely limited and fixed hardware versions so they can pre-compile shaders for that as part of just the game and it just ships with them. So that's why they don't have to deal with that. Whereas in the PC space, every graphics card could have, when it compiles shaders, can compile them differently. So they need different files for that. Also, even if you're on the same GPU, but with a different GPU driver version, you might have to compile shaders differently. And so because of that, games on the PC don't ship with the shaders already compiled for your hardware. It has to compile for your GPU and driver version when you launch the game. The idea behind this, this system is that servers could take care of all of the shader compilation for all of the different, GPU and driver combinations out there. And honestly, I'm not an expert on this. Whatever other hardware stuff or software stuff on your PC might trigger a different version of the shader, compilation being needed for you. But if that gets taken care of in the servers, and then is uploaded to the servers, and then your game just downloads the one you need for your specific hardware and software combination, then you don't have to do those shader burns when a game launches or have to have the stuttering happen. Now, for all of this to work, though, I do have some questions. So it's nice that Microsoft seems to be talking about how this process, their advanced shader delivery system, but this needs AMD, Intel and NVIDIA to participate. Looks like Intel's announcing their participation. That's good. But then I'm also just curious, who is hosting all of this? Who is paying for that hosting? Who is developing the software behind doing all of this? Is this all on Microsoft? I'm sure it needs collaboration with Intel, AMD, and NVIDIA. Is that collaboration happening? When will we start seeing this? In which games? So there's a lot of questions on this system, but I think that this is needed because right now the PC gaming setup in relation to shaders is far from ideal. And it's one of the things that consoles can do a lot better than PCs, because they just have limited hardware combinations. Anyway, the last news topic I want to talk about today is that some people, not me, did get early access to Battlefield 6 and have been able to deliver tons of benchmarks. So I just want to point you in that direction. Hardware Unboxed has benchmarked 43 GPUs at 1080p, 1440p, and 4K in Battlefield 6. Now, I'm going to direct you to their video. I'll link all my sources today in the video description if you want to see the actual benchmark charts. I'm just going to give you a few thoughts based on it. First of all, they are testing out the single-player campaign, not multiplayer. Now, this makes sense because in multiplayer, it's extremely difficult to get identical test runs when testing GPUs, whereas in a single-player campaign, it's much easier to do that. So it makes sense. But do keep that in mind. It is based on the campaign testing. Now, also, it's mostly done at native resolution, although they do have some upscaling results on certain GPUs. Now, based on all of this, I will say that the game does appear to actually be extremely performant, even at native resolution on a lot of GPUs, and it also looks like reducing graphics settings doesn't have a huge downside to the image quality of the game. But that being said, the game doesn't look completely boundary pushing or anything like that. It looks good and it runs well. And I think for a first-person shooter, especially one that's primarily multiplayer, that's what you're looking for. So definitely check out this video if you want all of the tests. It does seem to be the case that it's one of the games where AMD and NVIDIA GPUs that normally perform about the same on average, but in individual games, one outperforms the other. This seems to be a game where NVIDIA tends to outperform AMD. But not by such a wide margin that AMD GPUs aren't producing good results. So that all looks great. Performance-wise, like I said, check out their video for all of the full details. And I think the other thing that would still be interesting is definitely some CPU-related testing. Now, given that there's a lot of benchmarks like this out there, are you guys still interested in me benchmarking the game tomorrow when I get access to it? Because I didn't get any early access to the game, so I'd get it when it launches. Try to test it out if I can, but might have limited time to do so. I've already tested the open beta a lot. There's already huge benchmarks like this. So let me know the interest level on Battlefield benchmarks. Anyway, follow up on all the links in the video description for all of the original source material for all of this info and all these benchmarks here. And I hope you guys have an excellent day.